Good morning friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. Now in the earlier video we have discussed one example for converting an epsilon NFA to NFA. For better understanding in this video I am discussing another example. So let me discuss this example. So they have Q0 on A is going to Q0, Q0 on epsilon it is going to Q1, like that it is there. Whether it is an epsilon NFA or not, we need to check. First we need to check whether it is NFA or not. Q0 on A you have a move, on B and C you don't have moves. So how many alphabets are there here? A, B, C, 3 alphabets are there. So it is an NFA and you have epsilon moves, so I can call it as an epsilon NFA. The initial state is Q0 and final state is Q2. So, before converting the epsilon NFA to NFA, you need to calculate the epsilon closure of each state. What is the epsilon closure of Q0? Is Q0. From Q0 you can go to Q0. Q0 on epsilon where you are going. Q0 on epsilon you are going to state called Q1. From Q0 on 2 epsilons also you can go to Q2. So, what I can say, the epsilon closure of Q0 will consist of Q0, Q1 and Q2. Similarly, epsilon closure of Q1 is equal to, from Q1 you can go to Q1 and Q1 on epsilon you are going to Q2. Now similarly, epsilon closure of Q2 is, from Q2 on epsilon you will go to Q2 but you cannot go anywhere. Q2 on that one you cannot go anywhere. So this is the epsilon closure of Q0, Q1 and Q2. Then what should I do? I have to find the transition table from the transition diagram. So transition table for the epsilon NFA is, you have Q0, you have Q1, you have Q2 on A and B. Now Q0 on A, where it is going? Similarly you have C also, I forgot to mention. Okay, Q0 on A, where it is going? Q0 itself. On B, is it going anywhere? No. On C it is not going anywhere. Q1 on A is not going anywhere. Q1 on A is not going anywhere. On B it is going to Q1. On C it is not going anywhere. Similarly Q2 on A it is not going anywhere. On B it is not going anywhere. On C it is going to Q2. Now which is the initial state? Q0 is the initial state and Q2 is the final state. Okay. Now we need to find the transition diagram for NFA. It's not the transition diagram. Anyway, we have to find the transition diagram. Before that I need to find the transition table. So transition table will have how many states? 3 alphabets will be there, and how many states? As the procedure will say that then the number of states in the epsilon NFA and NFA will not change. So as you have 3 states, the 3 states will be there. And which is the state will act as an initial state? Which one will act as initial state? The state which is acting initial state in epsilon NFA will act as a initial state in NFA also. Now we need to find Q0 on A where it is happening. So Q0 on A, if you want to remember, the procedure is you need to calculate the epsilon closure of first Q on X. For that one you need to calculate the delta. For whole one you need to calculate epsilon closure. If you remember this step or this one, you can easily convert any epsilon NFA to NFA. Now as I need to calculate Q0 on A, so epsilon closure of Q0 I will calculate. What is the epsilon closure of Q0? Is Q0, Q1, Q2. Am I right? Now Q0, Q1, Q2 on A, where it is going you need to see. Q0 on A is going to Q1, Q0. Q1, Q2 on A, they are not going anywhere. So this entire one you will get Q0. Is it clear? Now epsilon closure of Q0 is Q1, Q2, Q1, Q2, Q2. So Q0, Q1, Q2 you will have. Are you able to understand it or not? I need to calculate Q0 on A. What is the transition? First I will calculate the epsilon closure of Q0. Epsilon closure of Q naught is Q naught, Q1, Q2. Q naught, Q1, Q2 on A where they are going. In place of X, you will keep here A. So, from the Epsilon NFA, Q naught on A is going to Q naught, Q1, Q2 on A, they are not going anywhere. If you union them, you will get Q naught. Then, for this entire one, the result is Q naught. Now, epsilon closure of Q naught you need to find. What is the epsilon closure of Q naught? Q naught, Q1, Q2. So, that is the state. So, Q naught on A, you will go to Q naught, Q1, Q2 separately. Means, these are the three states, three separate states, not a single state. Now, similarly, Q naught on B, how I will get? Q naught epsilon closure I will calculate, it is Q naught, Q1, Q2. On B where it is going, Q naught on B is not going anywhere, Q1 on B is going to Q1, Q2 on B is not going anywhere. So, you will get completely Q1. So, epsilon closure of Q1 is Q1, Q2. So, Q naught on B is going to two states called Q1, Q2. Now, on C, so first you need to calculate epsilon closure of Q naught. Epsilon closure of Q naught is Q naught, Q1, Q2. Q naught, Q1, Q2 on C, if you do, you are going only state Q2. Remaining two are null states. So, epsilon closure of Q2. Epsilon closure of Q2 is Q2. Is it clear? Are you able to understand it or not? So, we got Q naught on A, on B and C. Now, we will calculate Q naught on A. So, first if I want to calculate Q1 on A, I need to calculate epsilon closure of Q1. What is the epsilon closure of Q1? It is Q1, Q2. Now, Q1, Q2 on A, where it is going, you need to check. Q1 on A is going to, if nowhere it is going, Q2 on A is also not going anywhere. So, this is your empty. Epsilon closure of empty is epsilon closure of empty is empty. So, you will not go anywhere. Q naught on A, you will not go anywhere. As it is in NFA, it cannot go anywhere also. Meaning is that from Q naught on A, you no need to move any, you no need to represent any translation. So, it is valid. Now, similarly, Q1 on B. Q1 on B, if you want to calculate, first you need to calculate epsilon closure of Q1. Epsilon closure of Q1 is Q1, Q2. Now, Q1, Q2 on B, where it is going, you need to see. Q1 on B is going to Q1. Q2 on B is not going anywhere. So, if I do union, I will get Q1. Now, epsilon closure of Q1. Epsilon closure of Q1 is Q1, Q2. Is it clear? Now, similarly, if you see that epsilon closure of Q1, I need to calculate Q1 on C. So, epsilon closure of Q1 is Q1, Q2. Q1 on C, anywhere it is going? No, it is not going anywhere. Q2 on C, it is going to state called Q2. So, if I do union, I will get a state called Q2. Now, this total one, I got Q2. Now, epsilon closure of Q2 is Q2 alone. So, Q1 on C is going to Q2. Now, Q2 on A I need to calculate. First, I need to calculate epsilon closure of Q2. Epsilon closure of Q2 is Q2 alone. Q2 on A is going anywhere? No. So, epsilon closure of anywhere is nowhere. Is it clear? So, similarly, Q2 on B, epsilon closure of Q2 is Q2. Q2 on B is not going anywhere. So, epsilon closure of not going anywhere is not going anywhere. Is it phi or not? Okay. Now, similarly, epsilon closure of means Q2 on C I need to find. Epsilon closure of Q2 is Q2. Q2 on C is going to Q2. So, this entire one you got Q2. Now, epsilon closure of Q2 is Q2 alone. So, we found the number of states Q0, Q1, Q2 and the alphabets are A, B, C and the initial state is Q0. Now, what are the states will act as a final state? Now, in the epsilon NFA, Q2 is a final state. So, Q2 is here, Q2 is here, Q2 is here. If you remember the procedure, what are the states epsilon closure consists of final state? They all will act as a final states in the NFA. So, epsilon closure of Q0 is having final state. So, here in NFA, Q0 will act as a final state. Q1 is also consists of Q2, even it is also act as a final state. and similarly Q2 is also having, so it also will act as a final state. Okay, so we got the transition table. Now once you got the transition table, we can easily construct the transition diagram. Let me erase this one so that we can use this space. Now, how many states you will have? You will have Q0, you will have Q1, you will have Q2 states. So 3 states are there. Now Q0 on A is going to Q0 itself. Q0 on A is going to Q0, Q1 and Q2. Done. Now Q0 on B is going to Q1. So I will write it as A comma B, and it is going to Q2 also. Now Q0 on C is going to Q2. So meaning is that Q0 on A comma B comma C is going to Q2. So instead of writing multiple edges, I am writing like this. So Q0 on A comma B, it is A comma B. Sorry for my handwriting, please bear it. Okay, Q0 on A comma B is going to Q1 comma Q1 on A and B. So that's why I have represented. So Q0 on A, B, C we have represented. Q1 on A is not going anywhere. Q1 on B is going to Q1 itself, and on B it is going to Q2 also. On C, Q1 on C also it is going to Q2. Is it clear? Now Q2, come to Q2. Q2 on A is not going anywhere. On B it is not going anywhere. On C it is going to C itself. So we have constructed the transition diagram for the NFA. Is it clear? Are you able to understand? Now remember this point. What is the point 1? There will be no change in the initial state. So here it is Q0 is initial state. Here also it will be the Q0 is initial state. There is no change in the number of states. Here you have 3 states, and in NFA also you have 3 states. And there may be a change in the final state. So which are the states are acting as a final state? Q0, Q1 and Q2. All 3 states are acting as a final state. So we have got the equivalent NFA from the given epsilon NFA. Okay, I hope you have understood how I done the conversion. If you have any doubts, feel free to ask in the comment section. I will clear your doubts in less than 24 hours. If you really like my videos, please press the like button and give your positive feedback or negative feedback in the comment section. If it is a positive feedback, it will motivate me to teach further. If it is any suggestions, I will try to improve myself. And please subscribe to my channel, and there will be a bell button is there. Please press it so that you will get the regular updates. Thank you so much.